All right, so we've got yet another unit of concentration. In this case, we have molarity, capital M. And capital M here is equal to your moles of your solute over your liters of solution, right? So that's the volume of the solvent and all the solutes. And here's just a picture of how you would make a solution in terms of molarity. So you have some compound, right? You weigh it out, you add it to some kind of volumetric flask, you add your solvent, and then you fill up until your mark, right? So in this case, he wanted to make, half a liter, 500 mLs. So you use an instrument that allows him to do so, and then you fill up, right? And so in this case, in the liters of solution, it would be half a liter or 500 ml. So let's go ahead and calculate the molarity of this picture. So remember, the molarity is equal to your moles of your solute over your liters of solution. And so let's see what we're given and how we can plug these values in. So we have moles of solute. Moles of solute is not given to us directly. However, we have the identity of the compound that we're using and how much of it we have. So anytime we have grams, we should be able to easily convert to moles, right? This is a skill that you really should become second nature at this point. So we have 10.0 grams of cobalt chloride dihydrate. We will learn about hydrates in this course. You'll learn about it when you go to Chem 101 and 102, but basically it just means that there's two water molecules attached to it. Anytime we want to go from grams to moles or vice versa, we use the molar mass. So if you find the molar mass of copper 2 chloride dihydrate, you'll find out that it is 163.85 grams per mole. Grams down on the bottom, that way it cancels out with the grams on the top. And then you do the math there, 10 divided by 163.85. You get 0.06131 moles of your solute. Cobalt. I've been saying, did I say copper before or cobalt? Hopefully I've said copper or cobalt. Cobalt 2 chloride dihydrate. And we're going to take this value right here and plug it into there, right? So you see it's a plug and chug plus conversion types of problems. And then finally, the other thing we need to know is liters of solution. We can see that our solution goes up to 500 ml. So we would take 500 ml, and then we need to convert that to liters of solution. So for every 1000 ml, we have 1 L, and that would get us to half a liter or 500, half a liter, 0.500 liters. And then we just plug those values in and go ahead and do the math, and you should end up with 0.122 molar, right? That's the concentration of your solution. Let's take a look at another question. So in this case, we have 2.0 liters of 3.0 molar NaCl. So notice when we use the capital M, we mean there is molar, which has to do with the molarity, right? So that's just the other way to say molarity is molar. Of some kind of sodium chloride aqueous solution. So we've got salt water. How many grams of NaCl? And again, we want to start off with a thing that's not a conversion unit. So here we just have 2.0 liters of our solution. And then we think about what other values were given in the question, right? We know it's 3.0 molar, and we can think about which way we write that. So remember that molar is equal to moles of solute. So in this case, we have 3.0 moles of NaCl over the liters of solution, and then we can just put 1 down there because 3 divided by 1 is equal to 3. And then we simply just plug that into here. We want liters down on the bottom, so 1 liter solution down here, 3.0 moles of NaCl, liters of solution, and liters of solution cancel out. Now note that our question is asking for grams of NaCl. Here we're only at moles. Again, at this point, converting from grams to moles should be second nature. So the molar mass of NaCl is equal to 58.44 grams per mole, We want the grams on the top, so that way the moles cancel out, moles and moles. 58.44 here. Go ahead, plug and chug through this. So 2 times 3 times 58.44. We get about 350 grams of NaCl. Again, these are all just plug and chug and conversion type of problems. Watching this video or watching any video is not what learning is. Right? So maybe you watch this video and you're like, yeah, that makes sense. Or maybe you thought about it and yeah, that's confusing. That doesn't make sense. Either way, this is only the first step in the learning process, right? Learning really is an active process. So you really want to go ahead and start with those work-alongs, start with the homework checks, and then, stop by office hours or a tutor's office to get some help. In general, we humans are very bad at estimating how good we are at things. We often way overestimate how good we are. So even if you're feeling confident about this, go ahead, do a practice problem and see if you get the right answer, right? That'll objectively tell you whether you know or you don't know how to do these types of things.